So, AKS 32, level 3 question. Okay, so this is wanting us to identify the x-intercept, the domain, range, y-intercept, intervals of increasing, decreasing, and create a word problem using these characteristics. So, all I've done is read this. Okay, so this is going to be x-intercept, y-intercept, domain, range, intervals of increasing and decreasing.
I don't even have that.
Okay, so the first thing that I would do with this is I would graph it. So I'm going to hit that y equals button. Okay, and I'm going to hit second x squared x plus 4, close parentheses. Then I'm going to hit second graph. And when I do that, I'm going to look for when y is 0, what is my x? Okay, so when y is 0, my x is negative 4. So that means that my x-intercept is negative 4. Okay, when x is 0, what is my y? So when x is 0, what's my y? Well, y is 2, so that's going to be my y-intercept, which is going to be 2. If we actually look at our graph, so we hit the graph button, we're going to notice that our domain goes from negative 4 to positive infinity. So our domain is negative 4 to positive infinity. Our range, we're going to look at our lowest y value, which we can do that from the table or from the graph. Our lowest y value is 0, and then it continues up, so that's going to be positive infinity. One thing that I think y'all struggle with is increasing and decreasing values. So for increasing and decreasing values, first you have to decide, is it increasing or decreasing? So if we looked at the graph, is it increasing? Yeah. Yes. Okay, so it is increasing. Now where is it increasing? Okay, and that increasing values are going to occur for your x values. Okay, so increasing is going to happen between negative 4 to positive infinity because it constantly increases. Struggled with this AKS, okay? So let's go over it. First, we got to graph it, and then we're going to identify these key features, okay? So when I put this into my calculator, I'm going to go into that y equals button, okay? And I'm going to type 2 second x squared x minus 2, close parentheses, or you're going to hit that right arrow key, depending on your calculator, plus 3, okay? And I'm going to hit graph. When I do that, I see that I have a starting point. I see that my interval is going to be increasing, okay? And then I'm going to do my key features. But first, I'm going to go to this graph, the table. And so my table is a starting point at 2, 3. So starting point is going to be 2, 3. And for my domain, we see that it starts at 2 and then goes up. So we're going to go from 2 to positive infinity.
Is that a bracket?
That sounds terrible. Bracket, and that's a parentheses.
Why does it do that?
Because it does touch 2, but it doesn't touch infinity.
So you do 2 parentheses.
Technically, yeah.
Are you gonna mark it wrong?
No.
Okay.
Then your range is going to be from 3 to positive infinity. So from 3 to positive infinity. And we can tell from our graph, if we look at our graph, we see that it starts right here and then keeps going up. So for our intervals of increasing, we're going to use our domain because our graph is just increasing the entire time. Technically, this one has an absolute min, okay, but normally we don't talk about minimum and maximum with radicals, but for this one, we're going to have a minimum of 2, 3, okay? Now, in behavior, what's going to happen is, one second. There's my graph. Cheat codes, y'all. Cheat codes. It keeps clicking off. So, for in behavior, what's going to happen is I'm going to stand at 0, 0, and I'm going to look to the left. Okay, so as x approaches to the left, what's happening? As x is going to negative infinity, what's happening to my y values? Well, where are they approaching? Like, what's my lowest y value? 3. As x is approaching positive infinity, what is y approaching? Positive infinity. Okay? Again, we really don't talk about in behavior when we are talking about radicals because we know that it starts at one point and then just continues on. But with that being said, if it does ask you that question, this is how you write it. Okay? And really we could say as x approaches negative infinity, y approaches error or undefined. But again, probably not going to go into that. Okay? So on level 2, on level 2, it says, given the following piecewise function, which of the following represents the graph? Okay, here's the quick, easy way to recognize this. Okay, they're going to have one question on your interim like this. Okay, so the first thing you want to do is you want to know the difference between a shaded circle, which is going to be either greater than or less than or equal to symbols, okay, or an open circle, which is going to have no line underneath, right?
So
okay,
basically, the shaded ones is when the point is included, and the non-shaded ones not.
No line, no shade. No line, no shade. Okay, so if we look at our graphs, okay, we see this green piece right here. Okay, so that is a line at y equals 2. Okay, it's a constant line. And we see that it's a closed dot at x equals negative 2, right? So that means that in my inequality, it's got to have a line underneath, right? So I can cancel out answer choice C and answer choice D just based off of the fact that this is a closed circle, not an open circle. Haven't really had to do any math, okay? Then I'm going to look at my other intervals and make sure that they're right. Okay, these are all the same. Okay, so now we're going to actually look at, are these different? This is the interim review. These aren't different at all.
Yes, it is. X minus
What is it?
5.
X plus 5. Okay, so the only difference between these two is this x plus 5 and x minus 5, right? Okay, so what I want to do is I want to go into my calculator and graph that and see what the difference is. So when I type this into my calculator, look at how I do it. I say parentheses x minus 5 raised to the 1/3 power. A lot of y'all struggle with the cube root. You're going to hit that graph. Okay, and we're restricting it to where x is bigger than 4, right? So we're looking from here on. Okay, so we graphed x minus 5. So let's try graphing x plus 5, right? So parentheses x plus 5 raised to the 1/3 power. And I'm going to hit graph. Now, out of these, which one looks like this piece right here?
The calculator.
This one right here, right? Which is the first one, which was x minus 5. So what is our answer? A. Alright, so let's talk about this one. Ready? Okay, so if I take this and I plug it into my calculator, watch how I plug it in, because a lot of you made this mistake on your quiz. Hint, hint, this was pulled from one of your previous quizzes. So, negative 4, parentheses, x plus 2, okay? And this cubic root, okay, I'm going to raise it to the 1/3 power. Make sure you use your parentheses or you use that right arrow key to come down from the exponent. And then I'm going to hit plus 4. Okay?
You put 46.
Yep. So I'm going to hit graph. Okay.
So the starting point.
Does it have a starting point?
Yes.
Where?
At the top.
No, because that keeps going off the graph. So do we have a starting point? No. Is it increasing or decreasing? It's decreasing. Okay? Now, for domain, we're looking at our x values, right? So our x values go from left to right. We can plug in anything, right? Okay? So our domain is going to be from negative infinity to positive infinity. And our range is also going to be from negative infinity to positive infinity. For our decreasing interval, we're going to use our domain because it's decreasing the entire time. Is there an absolute max or min on this one? Nope. Okay. And then let's talk about the in behavior. Let's talk about in behavior. Okay. If I look at this graph, I'm going to stand at 0, 0, and I'm going to look to the left. What's happening to my y values? They're going up, right? So as x approaches negative infinity, y is approaching positive infinity. Okay? If I look to the right, x is approaching positive infinity. What's happening to my y's? They're going down. So it's going to negative infinity. AKS 39 is about growth and decay. Okay, so it says the value of a new iPhone is modeled by this function. Does this function represent an exponential growth or exponential decay? When we're deciding, we're going to look at the rate. Okay, and we're deciding if it's growth by if the rate is bigger than 1, and it's decay if its rate is less than 1. So is this less than 1 or bigger than 1? Less than. So it's going to be decay.
So if it's bigger than 1, it goes down. It's decay.
Yeah. Okay. Now, what is the rate of decay? Okay, it's not 0.9. Okay? So, yep, it's not 0.9. It's going to be 1 minus 0.9. So the decay rate is 0.1, or it's decaying at 10%. Okay? It says you place $2,500 into a new bank account that has a rate of 2%. How could you write a function to represent this scenario? Does this represent growth or decay? Okay, so are you gaining money or are you losing money? Gaining. So obviously it's going to be a growth, right? And we know that the growth function is a times 1 plus r raised to the t power, right? Okay, or now you know that. So you're going to take your initial amount, and that's going to be your a. You're going to have 1 plus, and we're going to take this 2% and change it to a decimal, which is going to be 0.02. And we're going to raise it to the t power. Yes, ma'am.
So A is the initial amount.
Simplified to 2,500 times 1 plus, 1.02 raised to the t power. Okay. So the value of a new PlayStation 4 game console is $279. And after 1 year, the value of the system will become $223.20. What is a function that could be written to represent this situation? Is it growth or decay? What is the rate? So first of all, what is this? Growth or decay? It's decay. It's decay. Okay? Because it's going from 279 down to 223. Okay? So now we're trying to figure out what the decay rate is. Okay? So we're going to take 223.20 and divide it by 279. Okay? And that's going to give me how much it decreased by, right? Like what rate it actually decreased by. So in my calculator, I'm going to type 223.20 divided by 279. And that's going to give me 0.8. Okay? So this is going down by 0.8. So what you're going to do is you're going to take 279, multiply it by 0.8, and we're going to raise it to the t power. No, I'm not in the studio.